Okay, we're in section 4.3 where we're going to prove triangles are congruent by what is called SSS, or side-side-side congruency. Side-side-side congruency by definition is if three sides of one triangle are congruent to three sides of a second triangle, then we can say that the two triangles are congruent because all three sides are. So if we look at it and say, in this particular instance, if AB is congruent to EF and BC is congruent to DF and AC is congruent to DE, then we can make the conclusion that triangle ABC is congruent to triangle EFD. Okay, because what we talked about in 4.2 when we talked about corresponding sides. So we have to make sure that the corresponding sides fit the true statement that we're trying to make. So we are going to be doing some type of a proof, but what I'm looking for when it comes to proving these things is we have to explain what the proof is. And basically the explanation is what we have here. This right here is an explanation of proof because for one, they give us measurements or they give us tick marks. If they didn't have that, we'd have to do it some other way. So first off, excuse me, we're going to look at these two triangles here. So they want us to decide whether the congruent statement is true. In this case, this is not a true statement. It's just a statement. We don't know if it's true yet, but we have to explain it. In order for us to explain it, we must make sure that the corresponding sides and how it's named holds up. So first off, we have the first and second letter of AB. So AB is the one tick mark. So now is YZ got one tick mark? Yes, it does. So I can say that AB is congruent to YZ. Next, I'm going to look at BC. BC has two tick marks on it. Second and third in the second triangle is ZX. Does ZX have two tick marks? Yes, it does. So I can say that BC is congruent to ZX. And then finally, does AC, which is first and third, is that congruent to YX? And it is. So I can say that AC is congruent to YX. This gets checked off, this gets checked off, and this gets checked off. I can say yes to all three of those. I can say yes because of side-side-side congruency. Triangle ABC is congruent to triangle YZX. All right, let's take a look at this one. They want us to prove that triangle RST is congruent to triangle GHK. So first off, I got RS, which is 3 tick marks, and I need to look at GH, which is, oops, it's 1. So right off the bat, I see that RS is not congruent to GH. So just by that one statement, I say, nope, it's not true. So I can say, just because I just looked at one, I can say no, triangle RST is not congruent to triangle GHK, okay? So you only have to show one that's not true in order to show that it's not true. But if it is true, you have to go through the whole entire process, all right? This is what is called proof by contradiction. So if you found out that something's not true, then it's just easy to say that it's not true. It's much harder to prove that something is true. So finally, we want to know if KLM is congruent to NLM. So first off, I got KL and NL. So KL is one tick mark. So KL. I want to see if it's congruent to NL, which it is because it's got the one tick mark. So I'm going to say NL is congruent, so that checks off. LM is congruent to LM. Well, even though there's no tick mark, I do know that LM is congruent to LM because of the reflexive property. So that does check out, which it's the same thing. And then finally, they want us to see if KM, which is 2 tick marks, is congruent to NM, which is 2 tick marks. So yeah, it is true, so that gets checked off. So since all 3 things get checked off, I can say yes, because of side congruency, triangle KLM is congruent to triangle NLM. Okay. Now, when it comes to using given coordinates to determine if triangle ABC is congruent to triangle DEF, we have no pictures, we have no tick marks, we have no measurements. So the only way that we can prove that these are the same length measures is by taking the corresponding sides and proving that they are the same length by incorporating the distance formula. So we're going to have to use the distance formula to help us solve this, because just drawing a picture and saying that, oh, they kind of look the same does not show proof. You have to tell me what exactly are the measurements in order to go further and showing congruency of these two triangles. So before we get started, we have to look at the corresponding side. So if I look at the statement that it's given to us, we have to prove that triangle AB is congruent to, or I'm sorry, side AB is got to be congruent to DE. I need that BC must be congruent to EF, and then finally AC must be congruent to DF. Okay, so I'm going to use these coordinates to help me solve. All right, if it's true, I keep going. If it's false for just one, I know that it's false for all of them, so I can say that it's not true. So first off, I'm going to look at AB. So looking at AB, I'm going to use the distance formula. So it's going to be, looks like 1 minus 4 squared plus 2 minus a negative 3 squared. Let's cross the line, change the sign. 1 minus 4 gives me negative 3. Negative 3 squared is 9. Plus 2 plus 3 is 5. 5 squared is 25. So the sum of 9 and 25 give me the square root of 34. Well, since 34 is not a perfectly square number, I'm just going to leave it at the square root of 34. Let's take a look at DE now. So now I'm going to apply the distance formula. So I go over here. Looking at the coordinates, I can say 4 minus 7 and 7 minus 2. So 4 minus 7 gives me negative 3. Negative 3 squared is 9, plus 7 minus 2 is 5. 5 squared is 25. And that equals the square root of 34. That checks out. They're both the same. Now I need to see BC is congruent to EF. So BC, use the distance formula. So I'm going to say that it's going to be 4 minus 2 squared plus negative 3 plus 5 squared. 4 minus 2 is 2. 2 squared is 4 plus negative 3 plus 5 is 2. 2 squared is 4. So this gives me the square root of 8. I go over here and I need to find EF. So I go over here and it's going to be what? 7 minus 5 squared plus I'm sorry, this one's screwed up. This one here should have been negative 3 minus 5. Negative 3 minus 5 is 8. Negative 8 squared is what? 64. And then this should have been square root of 68. Sorry about that. That would have made a mistake. And then go into EF, go into the y values. I would have said 2 minus 10 squared. 7 minus 5 is 2. 2 squared is 4. Plus 2 minus 10 is negative 8. Negative 8 squared is 64. This gives me the square root of 68. Both are true. Check it off. And then finally, I need to look at AC. So I go to AC. It's going to be 1 minus 2 squared plus 2 minus 5 squared. And go over here. 1 minus 2 is negative 1. Negative 1 squared is 1 plus 2 minus 5 is negative 3. Negative 3 squared is 9. Gives me the square root of 10. And then finally, I'm looking at DF. Go over here. I write 4 minus 5 squared plus 7 minus 10 squared. I go 4 minus 5 is negative 1. Negative 1 squared is 1 plus 7 minus 3. Negative 3. Negative 3 squared is 9. Gives me the square root of 10. All of these corresponding sides are equal. So I can check that off. And yes, because of side, 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 triangle ABC is in fact congruent to triangle DEF. If we're going to look at the second triangle, or second coordinates of this triangle, same rules apply. So the first thing I got to do is I'm going to look at AB. I'm going to use the distance formula, so this gives me 1 minus 4 squared plus 1 minus 0 squared. 1 minus 4 is negative 3. Negative 3 squared is 9 plus 1 minus 0 is 1. 1 squared is 1. 1 plus 9 is the square root of 10. Now I'm going to look at DE, which is the corresponding side of this in the other triangle. So I go over here, I got 4 minus 6 quantity squared plus negative 5 minus a negative 6 quantity squared. So this is a plus plus situation. So I get 4 minus 6, which is negative 2. Negative 2 squared is 4 plus negative 5 plus 6 is 1. 1 squared is 1. This gives me the square root of 5. Not true. So I can't say that those are true. So just because one statement's not true means that the entire statement is false. So I can say that triangle ABC in this situation is not congruent to triangle DEF. Finally, in this section, they want us to talk about stability in a figure. And then they want you to respond why. So I have two figures here in the screen. One is stable and one is not stable. And how you determine if something is stable is by having diagonal supports. So if a figure has diagonal supports, it is stable. If it does not, then it is not stable. So the figure on the left is not stable. And then they want you to explain why. Well, it's not stable because there's no diagonal supports. And this one here, oh, it has a diagonal support right here. So I'm going to say, yeah, it is stable. And why? Because it has diagonal supports. And that's it for that one. And that is also the completion of being able to prove triangles congruent by side, side, side. Hope this helps. Until next time.